Hello, Jason here from Instruō. I'm very excited to be able to introduce a project that I've been working on kind of on and off for the past 9 months to a year or so. I think I officially broke ground on the project on Christmas Eve 2024. But yeah, this is a lot of the ideas that led to this have been working away on in the background for some time. So it's a module design, which no surprises there. But if you have been following Instruō for the past year or two, we have released some things that were maybe a bit unexpected. So we did the Seashell, which is our first standalone semi-modular self-contained instrument, and then much more recently we did the Pocket Scion, which is that's been a really fun one to work on. It's a bit of a quirky instrument, but yeah, I'm still designing modules, and I thought let's go big. I've not done a big module for a while. I think a lot of the past years has been kind of expanding the range and building out utilities. There are definitely some really deep and powerful modules that were released, but I think Arbor and Looper were kind of the last that were really a bigger form factor. So this project, I was really keen to kind of roll back to the approach that started Instruō from the get-go. Like I originally designed the troika and documented the whole design process of that, and that was kind of the focus, more so than the end result, than the final product, the final module. I wanted to create like a video that was kind of showcasing the process, like more behind the scenes. It ended up being a bit more abstract, and it was like Timelapse and audio, and kind of just showcasing the design process. So I've gone a bit further with this design. So this is a bit more of a comprehensive documentation of the entire design process. So this is the Ceithir. This is a rather big module that I've been working on. It is a quad state variable, resonant filter, quad oscillator, mixer, wave shaper. Yeah, it's kind of inspired from a lot of things that I've been like looking at and studying, and like I think there was a particular module that definitely showed up on Reverb at one point that I was like, oh, that's completely unaffordable. I should just work on my own version. So that's what this has kind of ended up being. It is 58 HP. I don't think I could have made it any smaller. I think it kind of definitely grew like as I was like drawing out the designs. But yeah, there's another revision to go following this, like of a few things that I've tweaked on this latest build. But this is the prototype. This is the unit that I've been actively testing with and playing with, and it is a lot of fun. So yeah, I've kind of approached this project without a time frame or without much of a plan in mind. Like, this exists and it's in my case, but I don't really know what to do with it next, because I'm still very new to actually patching with it, because it's been such a hypothetical and theoretical like concept. It's very much based on experience of different modules that I've designed in the past years. So the most obvious one being the 1047. So this is another multi-mode Resonator filter, but this is kind of the inspiration for the whole thing in terms of the circuit topology. This is based on the ARP 2500 1047, and it's just a really versatile and powerful filter circuit. So I've kind of taken that and expanded it considerably and added in a lot of weird stuff under the hood. Yeah, some ideas that kind of snowballed. There's a bit of feature creep here and there, but yeah, it's been fun. So this video is a bit of an overview of the project. I just wanted to introduce it because I'm going to be showing this module off a bit at this year's Resonator in Bristol. Yeah, I'll be doing one of the DivKid stage talks where Ben actually has one of these, because he was up in Glasgow for a trip when we were working on some Pocket Scion content, and yeah, we actually shot a session in studio here where it was me giving Ben a rundown of the Ceithir. So he's had one for the past weeks.
I'm really happy with it. As silly as that patch is, it sounds great.
Yeah. I think in Bristol, he's kind of going to be schooling me on what he's discovered patching with this, because I've racked this up in this case and been patching with it a bit for the past week, but I'm still just scratching the surface. Like, there's so many possibilities and so many options with this monstrosity of a module. So yeah, that's going to be quite fun, because I'm going to be learning some patching approaches that I've not thought about yet, because I've been busy tracing the boards and coming up with the interface and the graphical layout and stuff like that. So yeah, it's kind of done backwards, but because this is kind of a combination of different modules that I've designed in the past. So filters, all pass filters, modulation, mixers, limiters. Yeah, there's a lot going on. Yeah, I'll probably jump to a few different things in this video. I have shot a bit of hopefully a brief overview of the ins and outs of the filter. I'll probably try and truncate that a bit, because I don't want this video to be too long, and I'll show some little excerpts of the content that's to come, because this project itself is effectively going to be a video series where I'm going to be releasing the sort of sections and episodes that I've shot or like edited down from the whole design process. So it starts with me just working on my laptop back at my mum's place over Christmas holiday last year, and I just sort of had a notepad of all the ideas, all the things that I wanted to include in this, and then just started sketching. So I've got full time lapse of a lot of that progress. So I'll probably be showing that on screen at the moment. So the process of laying out all the jacks, pots, switches. The controls, coming up with the short list of actual features and interface that I needed, and then jumping between. I think I was still using Eagle for like the interface layout, just because that's kind of my comfort zone. That's where I got into doing a lot of this. So it's jump between that and then Illustrator, and then there are iterations of different prototypes where I actually like split the design into 4. So I designed a sort of singular filter module version of it that I could prototype with, and that had a couple of revisions that took a bit of circuit bending. So I've got some sessions where I've built and found mistakes and tweaked and circuit bent and modified the various prototypes, and then I'm kind of walking through a lot of the changes that I've done, and like showing that on like top-down camera, and exploring different mistakes or quirks with the circuitry. So it's been a big project, but it's been a nice side focus while things have been chaotic with Seashell development or Pocket Scion. But I've kind of had a comfort zone of a module design that's just always been there in the background for the past year or so. I hope you enjoy. I'm not sure exactly how many episodes this series is going to be, but I'm going to be writing up some articles and features on some of the things that I've found along the way, and I think I'm quite keen for this to be something that I do in parallel to future module designs as well. There's a lot of the modules that we've actually launched in the past year or two. I've got a lot of footage captured of the process, but this was the first time more actively capturing stuff with a sort of setup in mind for how I want to edit the episodes and stuff. So hope you enjoy. Thanks for watching. Okay, so I figured I should probably cover a little bit of the ins and outs of what the module does and sounds like, but I'll try and keep this brief. I'm going to save a full fleshed out overview video for its own video, because there's a lot to cover. So I'm going to focus in on the beta channel. All 4 filters are the same thing 4 times, although it's mirror imaged between the left and the right. But just in terms of camera framing, I think this is a good spot I found to show things clearly. If anyone's familiar with the 1047 filter from a good few years ago, a lot of similarities. It's the same state variable filter topology that I've sort of iterated upon for the Ceithir. So there'll be some similarities, but there's also a lot added in under the hood that's brings a lot more options to the table. So I'll just work from the top down. We've got our inputs at the top, input gain for the main input channel, as well as a limiter. So this limiter is effectively just a tanh, the same that's in the 1047 filter. Let me patch through it and we'll just listen to the low pass output directly to start with. We've got animation going on. There we go. I'm just patching a sawtooth source from a seashell. That's just off screen here, because this is a strange system that has no oscillators in it. There'll be some other videos on this particular setup at some point. So resonant low pass filter. The gain position when the input tanh is engaged, the 12 o'clock position for this knob is kind of a calibrated sweet spot. Yeah, it's very much optimized for modular level signals. If the limiter is disengaged, you drop a little bit of amplitude, but you can make that back up, and it won't shape the linearity of the incoming signal. But a bit of tanh distortion goes a long way. Cool. Inverting input, that stayed the same from the 1047. I can't remember the specifics of the original ARP 2500 1047, because it's got a secondary input as well, which does the similar quirk. I'm not sure if it inverts or not. I don't know if that was compensated for, but the way this works is you can hear that amplitude of the secondary input is inversely proportional to the resonance amount. So it's almost like a built-in crossfader, especially when you're CV modulating the resonance. You can get some quite nice results where you're crossfading between sources. Let's go back to our primary. Okay, so we have coarse frequency, fine frequency for our cutoff. We then have volt per octave input, which is calibrated to track volt per octave, of course. We have our resonance control, CV over resonance. There's this jack here as well. So this is the strike input. If I drop to low frequencies and send it a square wave, there we go. Pinged, resonant, tonal, percussive stuff, which is nice, especially when we're like driving into limiters. More to come. So that's the strike input. That's optimized for receiving rising edge signals to ping the filter. Back to sawtooth. CV over FM, which has got an attenuverter on it, same as the 1047. Then we've got these knobs here. So this one, if anyone's familiar with the 1047, might be familiar. So this is our notch output, but on the 1047, it's a variable notch where you can actually offset that center frequency peak. A bit of a quirk here. So we can see at the bottom, we've got our output section. We've got low pass, band pass, high pass, and notch. So these are all the parallel filter types from the state variable filter. High pass. The notch, this is actually new. It's a different point in the circuit I'm pulling from versus the notch on the 1047. So this one is the offset variable one. This one is just a fixed notch response. And that sort of phaser type sound. This one's a little bit more susceptible, so as you like bring up the resonance, it becomes a bit more subtle. Which can be quite useful. If we go down to our stereo output stage, this is what the variable notch, or I kind of refer to this as the morph control on this filter, more so than variable notch, because it does more than just variable notch. So output in stereo here, we've got a built-in limiter, which is different from the tanh on the input. Send some high resonance. So the way the filter's designed with this limiter is the aim was to remove any hard clipping. Even if the resonance really peaks out, it just softens any edges, so you get some distortion points, but it's very different from if it's just hard clipping the rails. Okay, so left output, I've got this switch here in the down position, so that's the default, so that's low pass, sorry, high pass, and then this is our variable notch offset, or morph control. So all the way to the left, and this is now our low pass response. All the way to the right is our high pass response, and then somewhere in the middle is our variable notch. What I've done differently here, a couple of things. Under the hood, this is now more of an equal power crossfading circuit, so there's a bit less of a loss in amplitude versus the 1047. And also I can change the high pass to a band pass, so it means I can morph from low pass through to band pass, which is a bit more subtle in most contexts, but it also changes things quite radically. Like you get that shift in phase, so you're going from sine to cosine in terms of like the self-oscillation response, but you get just a movement and phase shift that's a bit different from the variable notch. Cool. And the main big difference to the 1047 is each filter on the Ceithir is a stereo output. So there's stereo enhancement, as I've sort of, I'd best describe it. Okay, so let's bring this down here. Let's go low pass, a bit more resonance. So I'm now listening from the stereo left-right output. I've got stereo width all the way down, and as I bring this up, this is going to introduce our stereo width, stereo enhancement. And this is very, very much a go-to patch of mine, where I'll use the DAP, which is the 4HP dual all-pass filter, and I'll use that as a means of creating a differential between phase content for creating stereo enhancement. So that's exactly what's going on under the hood here as I bring this up. Okay, I'll do this sweep again with no stereo enhancement. So that's perfectly flat down the middle. But then with the stereo width added, we're getting a little bit of shift between the two, and that's because there's a differential of phase displacement between left and right. The left channel in this case is fixed, and the right channel is being modulated through a one-pole all-pass filter. And it's being modulated by its own built-in LFO, which is controlled from this global section here. So another thing to bear in mind is there's actually also a VCA built in at this stage. So the source from the morph control goes through its own VCA, controlled from the mix stage, and that goes before the all-pass filter, so it means that it's working as a stereo VCA for that end result. And as I bring up the rate, it goes fast enough that it becomes more of an artifact. But here you might be able to hear, if you're on headphones especially, there's more prominent movement on the right channel versus the left. And this flips if I change over to being this channel here. Let's get a similar position. There we are. You'll hear that it's the left channel. So the mirror image, I kept the right channels as the static, and then the left channel is the phase modulated, whereas on the left channels, left is static, right modulates. I did this so that if you are summing together in mono, not in mono, in stereo, but as a combination of the 4 stereo sources, it's kind of alternating and distributing that a bit. So because of the way I designed this circuit, there is an extra little quirk that if I switch back to being just mono, but if I change this to being sourced from my right channel, there we go, a little bit subtle, but that's it. Fully wet, so through the all-pass filter with quite a fast modulator, and we're hearing that sort of faux vibrato type effect. Because on the right channel we're hearing this cross mix between direct morph source and the all-pass filtered version. So it means that if I set this to the middle and we're getting a 50-50 mix of morph and phase modulated morph, it changes into this phaser response. And that's because we've got a combination of the phase modulated version cancelling out between the non-phase modulated. So we get this sort of resonant removal. So yeah, each channel of the Ceithir is also a phaser. And an extra step further here, these CV input jacks, they break the source from the built-in LFO, so it means that you can use this as externally CV controllable over the phase shift. Again, this is a weird system that I don't have any modulation sources either, so yeah, there we go. Shift and phase. Cool, okay, let's go back to stereo and let's look at some of the deeper features of the Ceithir. The two pairs of channels on the outer sides, see each one's got this sort of center switch. If I engage this, it's actually combining the controls of the leftmost or the controls of the rightmost to the center. So it means if I center these controls, I've got parallel shift. So it means that if I'm sending the same signal to both channels, I can create an offset and get variable peaks between a single filter's controls. If I jump over to the center, here we go. Here's a mult. We'll be able to hear this. Let's set resonant peak quite high for each. And let's go full bandpass for each. There we go, so we've now got that Joe peak movement controlled from the leftmost filter. And that pertains to the right as well. You can do the same thing controlling the right. So I mean, you can use it as a parallel pair of twin peak filters, with the addition of having a center control that sweeps through all. It controls all 4 center frequencies in parallel. Yeah, some pretty fun sounds. Okay, let's look at modulation a bit more directly here. So far we've heard the built-in modulators in the context of what their primary role is, and that's for the phase modulation, for the stereo spread. There's a collection of toggle switches here that are for an internal modulation bus, essentially. So if I look at the beta switch here, center position's off, down is FM, and up is animate. So if I go to FM, and here we've now got some built-in movement over the filter cutoff. And what this is doing, for every switch that I choose, either animate or FM, it's redistributing the other LFOs to map to different parameters. And this does it through a rotational pattern across all 4 filters. So in this case, the beta, the second LFO here, is modulating my stereo width, but I now have the next LFO, so the gamma filter's phase modulations rate is now controlling the frequency, or the cutoff frequency of the beta filter, which means I've just got a little bit of movement if I need it. Static, modulated. And that's normaling to the FM input jack, so it means I can still control the depth via the attenuverter. If I toggle up, we just get a lot of constant shifting movement, and that is because with animate engaged, I'm taking the other 3 LFOs, the same ones now routed to FM, but I've got additional ones where I've got the delta and the alpha LFOs mapped in, I can't remember which order it is, but they're going to the resonance control CV as well as the morph control. So it just adds a little bit more movement. I kind of landed on this when I was experimenting and developing the prototype, so I just patched all the LFOs that I could from an oct into every parameter, and it just sounded great, like just this sort of complex spread. So what I'll do, let's change to hearing 2 filters. Let's get these to a similar control position. Limiter's on. Cool. Okay, so if I mute that. So bringing up the gamma level, that's my gamma filter source. If I engage FM, again we're pulling the LFO that does this one stereo enhancement, but it's now modulating the frequency. But if I go to animate, we're just adding a lot more movement. So if I now bring up both levels, we've got this extra degree of phasing split between everything. And we're listening to the combined stereo output from the mixer section. There's a bit of a quirk here. So the left position of this toggle switch here, that's kind of the default, and that's going to sum all 4 stereo sources to a stereo output. If I engage the switch to the right, what this is now doing is the left channel is a sum of the 2 right outputs of the 2 left filters, and the right channel is a sum of the 2 left outputs of the 2 right filters, which means that it's a combination split left-right of the 2 pairs of filters, and it's sourcing from the phase modulated versions of their morph controls. which is a bit of a mouthful, but it means that there's kind of maximum movement where I could split the morph control, and this is now acting as the phaser because it's a mix of the morph and the all-pass filtered morph. So we're just getting maximum movement over stuff, but I can also tame it a little bit by centering my FM. We're kind of just getting this twin peak sort of movement again. Let's go to higher resonance. There we are. Some parallel twin peak movement between hard left, hard right compared to this, which is more of a combined stereo spread between the two. Cool. Okay, so this has all been each filter in its filter mode. Let's cut back down to just one. I'll mute the input and let's just listen to this guy direct from the low pass output. So this is similar to the 1047, where if you have resonance maxed but the feedback disengaged, the filter won't stably self-oscillate, so you're going to hear nothing even if resonance is maxed. If you wanted to self-oscillate, that's where you can switch it into resonator mode. Oh, still got modulation. Let's turn that down. Here we go. So this is now a very clean sine tone self-oscillation coming from the low-pass output. And this is essentially a quadrature oscillator mode, where low-pass, band-pass, high-pass are going to give you sine, cosine, and then 180 flip of our sine. So we just need one more inversion of the bandpass one, and you'll have full quadrature. What you will hear, so I matched this response to the standard response I get in the 1047, where the amplitude of the resulting signal is frequency dependent. So as I do a sweep, to me it sounds like a very nice equal loudness. It's not a perfect match for the Fletcher-Munson equal loudness curves, but it's not far off. I think it just lands in that, following that sort of trend where it stays very musical. So sequencing it as a sine wave oscillator, it stays quite consistently loud for across its frequency range, which is also a bit of a downside of the 1047. Like if you want that, that's great, but if you want something that's got a stable amplitude, say you're using the sine wave result into a wave folder, the amplitude is going to be a factor of how much there's wave folding, so consistent amplitude is going to be more important. That's where the oscillator mode comes in. So that stabilizes the amplitude across the full frequency range, which took a bit of trial and error to get that circuit to behave itself. And there are a few quirks and caveats, but they've ended up being quite interesting and quite useful. So this is the low pass output. So this is calibrated for the oscillator mode to give us a clean, stable sine wave, balanced amplitude across the full frequency range. But if I switch over to my bandpass output, that's a hotter signal. So the whole thing is boosted a bit. And that's just down to the part of the state variable filter that it's pulling these signals for the parallel filter types. And when I go to oscillator mode, I'm changing the gain stage between stages of the filter to gain that stability. High pass is a bit different, so it's kind of got a little bit of a kink in it if you view it on a scope. And then notch is like a cancellation result. It's like it's almost already high-pass filtered. Where I really liked this behavior is if we come from the morph output. If I set this to being low-pass morphing to bandpass, this now becomes a timbre control because I'm essentially increasing the amplitude of the resulting sine wave by cross-mixing from low-pass through to bandpass, which, especially if you've got the limiter engaged, it's an extra bit of CV control over timbre, which yeah, I kind of just kept in as a feature. I think that covers all the quirks of this. I guess other elements, the inputs, they cascade in normal. So if you patch to this input only, it normals here, and this also normals here, which normals here. So it means you could patch a single signal in and get that through all 4 filters at once, which sounds pretty wild. What else is there? The volt per octave jacks here. If we patch into this one, this normals to both of these, which also normals to there, which normals to these two. So it means you've got a common input as well as this common center frequency offset. Yeah. So who knows? I might do an expander for this module just to break out the access to the LFOs or do something else with that, because 52 HP is just the start.